etc. Most of them have general formula CXH2OY, and this is important to remember regarding the formula and keep this in mind. Most common sugar used in our homes is called sucrose, and carbohydrates are also called saccharides. And when we talk about biomolecules, we can say that biomolecules are molecules of compounds which is needed for life. Most of these are macromolecules or polymers of smaller and simple organic molecules which contains carbon, hydrogen and oxygen. And along with proteins and fats, carbohydrates are one of the three main nutrients found in food and drinks. Your body breaks down carbohydrates into glucose. Glucose or blood sugar is the main source of energy for your body's cells, tissues, and organs. And carbohydrates are found in a wide array of both healthy and unhealthy food, like bread, beans, milk, popcorn, potatoes, cookies, spaghettis, soft drinks, etc. And many of the monomers join or link together to form polymers. So, when you talk about the classification of biomolecules, we have mainly four categories coming under this, which are proteins, carbohydrates, lipids, and nucleic acids. And again, you can see in this screen like the classification of biomolecules into carbohydrates, lipids, proteins, and nucleic acids. And now we'll discuss about the important functions of carbohydrates. And carbohydrate is a major source of energy in animal body. So, if you are feeling a bit tired, maybe due to lack of carbohydrates, so doctors advise you to, consume or eat some rice or rice-based food, so which is rich in carbohydrates. And these are the essential components of production, temperature control, and proper functioning of different parts of the animal body. And milk has essential components like as lactose, and these are stored as glycogen. And excess of carbohydrates in the diet is converted into fat, and it is stored in the fat depot. And these are reserve energy materials of the body in liver and muscles of animals and starch in plants. And these carbohydrates are helpful in absorption of calcium and phosphorus in younger animals, and it helps to secrete digestive juices as well. Now, moving on to the classification of carbohydrates, you can see that carbohydrates are mainly classified into three. That is, first is monosaccharide, second is oligosaccharides, and third is polysaccharide. And what is monosaccharide? As we saw just now, monosaccharide is a carbohydrate which cannot be hydrolyzed further. What is meant by hydrolysis? It is the reaction with water molecule, and it is the smallest monosaccharide at the smallest unit that you cannot break down further into. And examples are glucose, fructose, ribose, etc. And next is oligosaccharides. And oligosaccharides are carbohydrates which gives 2 to 10 monosaccharide units on hydrolysis. And they are further classified into disaccharides, for example, sucrose, maltose, etc. And trisaccharides, for example, raffinose. And then we have polysaccharides. These are carbohydrates which yield large number of monosaccharides on hydrolysis, and example starch, cellulose, gum, etc. These are also called non-sugars as they are not sweet in taste. Then, as you know, polysaccharides are again divided into reducing or non-reducing sugar. And if you come into monosaccharides again, you can see that it is again classified into trioses. For example, glyceraldehyde, tetrosis, example, erythrose, pentoses, example, ribose, cellulose, then hexose, example, glucose, fructose, and heptosis, example, pseudoheptulose. So you can see here the structure of the three important forms of monosaccharide, which is glucose, fructose, and galactose. You can see that glucose and fructose have a ring-like hexagonal structure, whereas fructose has pentagonal structure. Keep the structure in mind because you can get questions based on these structures. And monosaccharides, as we earlier discussed, these are the simplest carbohydrates, and as I already told, you cannot break it again into simpler units on hydrolysis. Here you can see the structure of uh, D-glucose and D-fructose. That is the first one, aldose, like glucose example. They have an aldehyde group. What is an aldehyde group? You can see that CHO group which is attached to the top end. It is attached to the carbon atom in position 1. Then secondly, ketosis. That is example fructose, which has a keto group, that is CO group, usually attached to second carbon atom. So always remember aldoses and ketosis, which as aldoses have aldehyde group attached to one and ketoses have keto group attached to second carbon atom. Now, which are the common monosaccharides? Mainly, we have to see three commonly used monosaccharides like glucose, fructose, and galactose. Glucose is an aldohexose. It's also known by other names as corn sugar, grape sugar, blood sugar, and all that. And fructose or levulose, it is a sugar derived from fruits. And galactose is a sugar found in milk and in glycolipids, also found by the hydrolysis of larger carbohydrates. Now in the figure you can see the structure of glucose, which is very important, and as you know, biomolecules come under organic chemistry. So when you talk about the structure of glucose, glucose is correctly named as D plus glucose, where the D alphabet shows the configuration and plus symbol shows the dextrorotatory nature of molecules. And you can see the cyclic structure of glucose, and glucose exists in two forms, alpha and beta. Despite having the aldehyde group, glucose does not give test, and this behavior could not be explained by the open structure of glucose. So it was proposed one of the OH groups adds to the CHO group and forms a cyclic hemiacetal structure. And what is meant by hemiacetal? Hemiacetal is a carbon connected to two oxygen atoms where one oxygen is an alcohol, that is OH, and other is an ether, OR. Remember that R is a shorthand to denote any carbon chain. Hemiacetal structure is given by Fischer. And due to the drawbacks of open structure, uh, the hemiacetal structure was found by Fischer. And two cyclic hemiacetal forms of glucose differ only in configuration of OH group and C1 called anomeric carbon. These isomers alpha and beta form are called anomers, and six-membered cyclic structure is called pyranose structure. And it was found that glucose forms a six-membered ring in which OH at 6,5 is involved in the ring formation. And Haworth projection is a common way of writing a structural formula to represent the cyclic structure of monosaccharides with a simple three-dimensional perspective. Organic chemistry and especially biochemistry are the areas of chemistry that use the Haworth projection the most. And here you can see the open chain structure of glucose as well as the six-membered ringed hexagonal structure. And the structure of glucose is extremely important, and you have to study and revise this structure and the theory well. And these are the steps to draw open chain structure of a glucose molecule. Firstly, it's very easy to draw the structure. You have to draw six carbon atoms from top to bottom and draw extended arms for all carbon atoms and don't draw for the first carbon atom. Now draw hydrogen to carbon bond such that four are one side and one on the other side. The remaining spaces should be filled with OH group like see, on the left hand side, you should write only HO because always only oxygen should be bonded to carbon and not hydrogen. And complete ends with two single bonded hydrogen bond and one double bonded carbon. And now here you can see the structure of fructose. And what is fructose? It's an important ketohexose obtained along with glucose by hydrolysis of disaccharide sucrose. And mostly fructose is found in fruits, honey, and vegetables, and in pure form, it is used as a sweetener. It is a ketonic functional group at carbon number 2 and 6 carbon atoms in straight chain, just like glucose. It belongs to D series and it's a levorotatory compound. It exists in two cyclic forms, which are obtained by addition of OHHC5 to keto group, and the ring so formed is 5-membered ring and it is named as furanose. And importantly, you have to study the structure of fructose, alpha D fructose, beta D fructose, and alpha D fructofuranose and beta D fructofuranose, and learn this chart very well. And next important compounds which comes under oligosaccharides are sucrose, lactose, and maltose. And you can see the structure of sucrose. It is one of the common disaccharides which on hydrolysis gives equimolar mixture of D plus glucose and D minus fructose. So on hydrolysis, that is hydrolysis means when sucrose is added to water, we get C6H12O6, which is D plus glucose, and C6H12O6, which again is D minus fructose. You know, glucose and fructose has the same structural formula, C6H12O6. Now, secondly, what is lactose? Lactose is more commonly known as milk sugar since it is found in milk. It is composed of galactose and glucose. And since the levo rotation of fructose, which is minus 92.4 degree, is more than the dextro rotation of glucose, which is plus 52.5, the mixture is levo rotatory. So, thus, hydrolysis of sugar, sucrose, brings about a change in the sign of rotation from dextro, that is plus, to levo minus, and the product is named as invert sugar. Listen carefully, this is a very important reaction and probably asked for many previous NEET exams. And finally, we have got maltose, like it is another disaccharide. It is composed of two alpha D glucose units in which carbon 1 of one glucose of unit 1 is linked to carbon 4 of another glucose in unit 2. So the free aldehyde group can be reduced at C1 of second glucose in solution, and so it shows reducing property and it is a reducing sugar. And finally, we come into polysaccharides, which is again divided into starch, cellulose, glycogen, which are all important forms of polysaccharides. Firstly, starch. What is starch? It's very important. Just remember that it's a polymer of alpha glucose and it has two components, amylose and amylopectin. You can see the structure of both in the NCERT textbook. Just go through the structure. And amylose is water soluble component. It is having 15 to 20% starch. Chemically, it's unbranched long chain with around 200 to 1000 alpha D plus glucose units, and it is held together by C1 to C4 glycosidic linkage. Whereas amylopeptin is insoluble in water. That is a major difference between amylose and amylopeptin. That is, amylose is water soluble, and whereas amylopectin is insoluble in water, and it has 80 to 85% starch. And it is a branched chain polymer with alpha D glucose units held together by C1 to C4 glycosidic linkage, and branching occurs by C1 to C6 glycosidic linkage. And cellulose occurs in plants. This is a straight chain polysaccharide composed only of beta D glucose units. And please go through the structure of cellulose in the textbook. And it is the most abundant organic substance in plant kingdom. And it's a predominant constituent of cell wall of plant cells. You might have learned that in chemistry. And next is glycogen. What is glycogen? The carbohydrates are stored in human body as glycogen, and it is also known as animal starch because its structure is similar to amylopeptin and it's more highly branched. Mainly, it is found in liver, muscle, and brain. So, you know what happens is that suppose your body needs glucose, the glycogen is broken down into glucose by enzymes, And mostly glycogen is also found in yeast and fungi. So we'll end this session with the topic, and now in further sessions I'll be doing quick revisions with proteins and vitamins, enzymes, etc. And after all the sessions, I'll be uploading the most important MCQs from the lesson topic wise, which has come for previous year NEET examinations, and I think you'll be finding it really useful. And do not forget to watch my intro video, and please support my channel and subscribe. Thanks for watching.